Okay, so we're doing some simplification, some examples. These are straight out of your book, Chapter 1, Section 2. Your paper book, it's like page 10. If you're using the digital book, I don't know what page that sends a slide around or change each year as they add more stuff. But Chapter 1, Section 2 is where you're going to want to look. And what I'm going to do is I'm going to work these examples, the ones that are straight out of the book. Then you'll go and work the got it's. Then you can come back and check them. I'll have the answers right here for you. So let's start here. What is the simplified form of the expression? So as a reminder, 10 to the 7th power, your base is 10, your exponent is 7. So that means 10 times 10 times 10 times 10 times 10 times 10. Notice there's 7 of them. That's what that 7 means. And we all know how to multiply our 10s, so that is 10 million. This is a nice way to write it though, isn't it? Alrighty, another example. Now you got to pay attention here too when we have parentheses, and I'm going to talk about negatives and stuff when it comes to this too. But 0.2 to the 5th power means 0.2, and looks like I cut it off a little bit when I was writing it. So that's really 0.2 times 0.2 times 0.2 times 0.2 times, well, there's the 0.2, ran out of room anyway. So that's 2/10 times 2/10, right? So 5 times. If you multiply that out, that is 0.00032 or 32 hundred thousandths. That's fun to say. All right, so now let me talk about negatives before I move any farther. If I want to talk about the difference between two things. If I have negative 2 to the 3rd power versus negative 2 to the 3rd power, I've got to figure out what's the difference between them. This one on the left says take the negative with you. The parentheses force you to take the negative. So this one is negative 2 times negative 2 times negative 2. And then this one on the right is negative of, notice now this time it's kind of weird, I'm adding parentheses, 2 times 2 times 2. It says apply the negative afterwards. The negative does not go with the power. Okay. You're going to find in this case we're going to get the same answer anyway. So we have negative 2 times negative 2, right? Positive 4 times negative 2 gives us our negative 8. Over here, 2 times 2 is 4, times 2 is 8, so negative 8. The difference is, and let me give you another slide here, hang on a sec. The difference is if I give you this one. So like negative 3 squared and negative 3 squared. This is where the negative comes into play. This one obviously means negative 3 times negative 3. This means the negative of 3 times 3, or negative 1 times 3 times 3, if you prefer. Negative 3 times negative 3 we all know is positive 9. 3 times 3 is 9, but throw that negative on afterwards, gets a negative 9. So when your exponent is even, that's when it becomes a real issue for you. So again, it's a difference there you really do have to know about. Now here's where you should have gone to your book and worked these. These are the got it's, so Chapter 1, Section 2. Problem 1, the got it's. You should have already worked these. If you haven't, go back and do that, then come back here and check your answers. And if you don't get the right answer, because you can see my answers off here to the right, right here. If you don't get the right answer, come and check my work, and I'm going to do that here right now. So we're going to have A. That means 3 times 3 times 3 times 3, right? 3 times 3 is 9, times 3 is 27, times 3 is 81. And here, this is 2/3 times 2/3 times 2, sorry about the bad handwriting there, 2/3. That's a 3, I promise. Alrighty, so you remember how to multiply fractions. 2 times 2 is 4, times 2 is 8. So 8 on the top. And on the bottom, 3 times 3 is 9, times 3 is 27. 8 27s can't be reduced, so you leave it like it is. And then over here, the last one, let me get these other things out of the way here, make a little bit of room. There we go. We're going to have 0.5, or 5/10, right, 1/2, times 0.5 times 0.5. Which we can all, 5 times 5 is 5, times 5 is 125. 3 decimal places if you prefer, right? 0.125. That's one way to do it. Or you can straight up multiply them out. It's up to you. So there you go. Now, simplifying a numerical expression. So this is using our order of operations. Let me pop those in here real quick. There we go. Bring those along for the ride. What is the simplified form of each expression? So let's talk about them first before we do anything. Notice here, so again, grouping symbols, right? So you do the 6 minus 2. That's going to give you 6 minus 2 is going to give you 4. Bring the exponent along with it, so bring everything else down. Only one thing at a time, one item per line. Then our exponents are going to be up next. 4 to the third power is 64. Again, 4 times 4 times 4. Then the division divided by 2. On the other one now, again, we talked about this in the vocab. This fraction bar is actually acting as a grouping symbol. So like a secret set of parentheses right here. So we gotta, now within that, you have to use the order of operations again. So 2 times 2 times 2 times 2, right? Giving us 16. And then 16. So finish with your grouping symbols. So that's exponents within the grouping symbols. Now we have to deal with the grouping symbols themselves. 16 minus 1 is 15. And then we're down to division. 15 divided by 5 is 3. And there you go. The hardest part to remember sometimes is that fraction bar can be a grouping symbol. Okay, a few examples for you. Again, if you work these and you saw the right, you already have the right answer right here, you're good to go. You probably don't need to watch this part of the video. You can move forward. But if you didn't, you need to check one. I'm going to work them all real quick. So let's get started on that. A, we'll start with that. And A is, so we'll start with, here we go, thinking of our order of operations. We're going to start with our exponents. You know what, let me pop those order of operations back in here real quick. There we go. So we start with, there's my pen, the exponents. Or group, I'm sorry, there are no grouping symbols, so jump straight to exponents. That's what I'm trying to spit out. So we're going to have 5 times 7 minus, well, 4 squared is 16, divided by 2. Notice only one thing at a time. Bringing it on down. Now we're looking at the fact that we don't have any more exponents, so we're going to go ahead and take care of the multiplication and division as we come to them left to right. So 5 times 7 is 35. Bring down everything else, minus 16 divided by 2. It's a division sign, I promise. Still have some multiplication and division to deal with. 35 minus 8. 35 minus 8 is 27. So that's your first one, how I got that. B, let's see on here, no grouping symbols, no exponents, so we're down to multiply and divide, and we do have that. So we're going to have 12 minus, and 25 divided by 5 is 5. And 12 minus 5 is 7. That's how I got that. And C, we do have grouping symbols, if you remember. We had said that the fraction bar acts as a grouping symbol. So it's kind of like there's parentheses on top and on bottom. And please remember, once you have a set of parentheses, you have to work that as its own separate problem following order of operations inside those parentheses. So on this one, I'm going to start with the top, just because. It's kind of like working left to right if you think about it, top to bottom. And so within there, exponents are going to come first. So I'm going to have 4 plus, and 3 to the 4th is 81. And bring down everything else, 7 minus 2. And on the top then, I'm done with exponents, no multiply, divide up there. Yes, there's division, but I still have to finish the parentheses or the grouping symbols on the top. That's the fraction bar stuff. 81 plus 4 is 85. And bring down your 7 minus 2, or bring it over in this case. Now I'm done with the top, so let's deal with the bottom set. 85, 7 minus 2 then is 5. And 85, to finish it up, division, 85 divided by 5 is 17. So there's that one for you. Now the last thing here, D, how does a fraction bar act as a grouping symbol, and explain? Well, I think we've kind of covered that within our discussion here, but a fraction bar acts as a grouping symbol since you simplify the numerator and the denominator before you divide. So that's really what we're doing. But again, it's a grouping symbol. We talked in our vocab about evaluating algebraic expressions, and we do have an example of that here. And what that means is, I call it plug and chug, but we're plugging in numbers and then using order of operations. That's all we're doing. So what is the value of the expression x for x equals 5 and y equals 2? So everywhere that we see an x, we plug in a 5. We see a y, we plug in a 2, and then we use order of operations. So again, 5 in here, so that's 5 squared. 2 in here, that's 2 squared. Order of operations says, again, grouping symbols, don't have those. Exponents are up next. So the 5 squared becomes 25. Now here they cheat a little bit in your book. They go ahead and square the 4 at the same time. I guess, or the 2 at the same time. I guess that's fair, but then we take a look and we look at multiplication and division from left to right as we come to them. So we don't do 25 plus 5 minus 12, then divide by 4. So we do the 12 divided by 4, technically negative 12, so that's why you get the minus 3 here. Now we're done with multiplication and division, so we add from left to right and get our 27. Same thing here, plug in a, well, similar problem I should say, 5 in here and a 2 in here. Inside, dealing with parentheses, 5 times 2 then, 5 times 2 is 10, and then we square that 10 to get 100. Alright, so here's the got it. So again, if you got the right answers, you can see them right here on the right side. Feel free to move on to the last example. If not, check them right here with me. Then you'll know what I did differently. And don't forget you can ask questions if you need to in class. That's what I'm around for. Alrighty, so this time we're going to substitute 3 in for A. A is right there. And 4 in for B right there in both of these expressions and see what we get. So the first one we're going to have 3 times 4 minus 3 squared. Take a look there, see what I did. So deal with exponents first. So 3 times 4 gets brought down, minus 9. Done with exponents, so we have multiplication division. 3 times 4 is 12, minus the 9, which is a positive 3. And B, it's going to substitute in there, we have 2, and then times 4 squared. Notice only the 4 is getting squared, not the 2. Minus 7 times 3. I do put a slash through my 7s. I just want you to note that. I've done it since I took German in like middle school, and it just kind of stuck. So, alrighty. So exponents. Dealing with that first. So 2 times 16 minus, and then we're going to bring down our 7 times 3. 2 times 16 is 32. Bringing down the 7 times 3 again. 32 getting brought down, and then 7 times 3 is 21. Notice it's kind of cruising right through order of operations. And then 11 is the answer. So again, to make sure we understand what I did here, exponents first, then multiplication and division as I come to them left to right, and then addition and subtraction as we come to them left to right. Now part C asks us find the value of xy squared. Notice the difference. No parentheses, yes parentheses. This one, we only square the y, not the x. Here it's forced to square the x times y. That's the major difference there. So the two sides aren't going to be equal. So what that really looks like is we're going to have x is, where we get x is 5, right? 1 second here. So that's what we're really looking at. So 5 times 2 is 10, right? So 10 squared. And then that's 100. And here we only square the 2 because the parentheses don't say square the whole thing. So 5 times 4, which is 20. Big difference those parentheses make. Alrighty. You know, I mentioned this the other day. I love story problems. Love them, so we're going to include those here. Evaluate a real-world expression. So theoretically, they use this somewhere in the real world. Banking. What is an expression for the spending money you have left after depositing 2/5 of your wages and savings? Evaluate the expression for weekly wages, 40, 50, 75, and 100. Alrighty, so what do we know? We know that savings is 2/5 of the wages. You know, your wages can obviously vary. It looks like greatly here. We need an expression to find out the amount of money. And we're going to write one. So wages minus savings, that's what you have left over. That's what you wanted to know. So let W, and this is something I'm real big on when you story problems. If you're writing your own, I need what's called a let statement. Let W equals. Notice the word let in there. That's why I called it a let statement. So W is your wages. You're defining a variable. So your wages minus 2/5 of your wages. That's what we're looking for. So the expression is W minus 2/5 W. So you're looking at really having 3/5 W left over if you think about it that way. So on here, wages are $40, so $40 minus 2/5 of $40. And this is where simplifying it beforehand would have been kind of nice just to make it 3/5 W, right? 50 minus 2/5 of 50. 75 minus 2/5 of 75. 100 minus 2/5 of 100. And we can see the resulting answer there. So again, writing your own expression and using it. Don't forget that let statement. Alrighty, so here, shipping cost for an order online to store is 1/10 the cost of the item you order. What is the expression for the total cost? So in other words, the cost of the item plus the shipping. Okay, so we're going to start out with a let statement. So I don't know I do know the cost of the items. They're listed here, but theoretically this could work for anything. It's kind of generic, right? So let C equal cost of item. So in this case, our expression is going to be C plus 1/10 of C. So we're going to take each of these and plug it in. And again, we can make a table if you wish. So the first one will be 43 plus 1/10 of 43. So in other words, you're going to be adding on 430, right? So you're going to have 43 plus $4.30. Going to yield, and you can see all these up here, 47.30. Again, do the same thing for 79. And you're going to 86.90. And I guess we could write each of those out for you here. So we're going to have 79 plus 1/10. That's not really a very good 10. Let me fix that. Plus 1/10 of 79. So that's 79 plus 790. And that's going to be 86.90. And 95, so that one will end up being now what, 95 plus 950. And then 103 will be 103 plus $10.30. And those are our answers for each of those. So, alrighty, there you go. You have some homework over this as well. So I'll let you get to then.